Learning outcome 4.7. This learning outcome has three parts. Given x of t and h of t, calculate y of t and y of j omega using Fourier transforms. Given x of t and y of t, calculate h of t and h of j omega using Fourier transforms. And given h of t and y of t, calculate x of t and x of j omega using Fourier transforms. With our system, we have our input x of t, our system's impulse response h of t, and from those two we can produce the output y of t through the convolution of x of t and h of t. We've discussed earlier this chapter how all these terms can be written in the Fourier domain, x of t as x of j omega, y of t as y of j omega, and h of t as h of j omega, and how the convolution in the frequency domain becomes multiplication. If we are given two of those signals as inputs, and we want to find the third, doing an inverse convolution is not always possible. If we are given x of t and h of t, we can, in the time domain, find y of t. That's not a problem. But if we're given, for instance, x of t and y of t, and we want to find h of t, doing that inverse convolution is not the same as if we were to do an inverse multiplication, which we call division, or inverse addition, which we call subtraction. However, keeping in mind the fact that we can take this equation, transform our signals, and therefore our equation, into the frequency domain, we can change convolution into multiplication, and that we can do an inverse operation to, division. So if we want to find y of t given x of t and h of t, we can take our x of t, convert to x of j omega, take our h of t, convert to h of j omega, from those two produce our y of j omega, and from our y of j omega produce our y of t through an inverse Fourier transform. Similarly, if we want to find x of t, and we know h of t and y of t, we can take our h of t and y of t and convert them into Fourier domain, calculate x of j omega through division, and then from our x of j omega, invert the Fourier transform and form our x of t. If we want to find our h of t, and we know y of t and x of t, we take our x of t and y of t, convert them into the frequency domain by taking the Fourier transform, producing x of j omega and y of j omega. From those two, we can calculate h of j omega. And we can take h of j omega, invert the transform, and find h of t. We'll do one example for each case. So here you're given x of t and h of t. You could convolve these two signals, and you need to know how to, and quite often I'll ask you to do this through convolution in the time domain. But if we're going to try and approach it from a frequency domain approach, we would again take both those signals, convert to the frequency domain, calculate y of j omega, and then invert. So let's take our x of t, look at your table 4.2, what's x of j omega? Take your h of t, look in table 4.2, what's your h of j omega? I've then gone and combined these two terms. Now we can take our x of j omega and our h of j omega, combine them to form our y of j omega. In order to invert, we need to do partial fractions. Pause the video and work that out. And now we need to invert this, so look at table 4.2. We get our y of t. Next example. We're given h and y, and we want to find x of t. First step is to take h and y, convert to the frequency domain, Look in table 4.2. What's the Fourier transform of both these terms for h of t? Look in table 4.2. What's the transform of each of these terms for our y of t? Now recall that if y of j omega is x of j omega times h of j omega, we can solve for x of j omega being y of j omega divided by h of j omega. A lot of the terms cancel out. This is not by coincidence, because if this was our system and this was our output, part of the system characteristics will show up in the output. So we expect that some terms will cancel, not all. And this is the term that shows the characteristics of what part of the output came much more influenced from the input. Now we need to take our x of j omega and invert it to find our x of t. Look in table 4.2, and there's your x of t. Final problem. We're given x of t and y of t. We want to find h of t. Again, Fourier transforms for x and for y. So look in your table 4.2. What's the transform of x of t? Look in table 4.2. What's the transform for y of t? Again, y of j omega is x of j omega times h of j omega. Therefore, if we want to know h of j omega, we take y of j omega divided by x of j omega. A lot of the terms will cancel out. And we now know what our frequency response is. We want to invert this. That means partial fractions. Pause the video and calculate partial fractions. Now go to table 4.2 and find the inverse for each of these terms. There you go.